In this video, we're computing the definite integral of x times the square root of x minus 1 on the interval 1 to 2. And this is a classic sort of textbook calculus problem where what we're going to try first is to let u equal the interior of the square root function. So we let u equal x minus 1, and we take the differential of both sides, and we find that du is simply equal to dx. So in our integral, we'll have a square root of u now. But there's a problem hanging around out in front. We still have this lonely x that has to be converted into an expression in terms of u. So to do that, we go to our original definition of u, and we just solve that for x. So it looks like x can be replaced with a u plus 1. So that's going to transform the entire integrand in terms of u. In addition to that, I want to transform the limits of integration. So we can just go to u space and finish the problem there. So to transform the limits of integration, we just look at the values of u corresponding to the upper and lower values of x. So when x is equal to 1, I put that into my definition for u, and u will be 1 minus 1, or 0. When x is equal to 2, I put that in my definition for u, and I get 2 minus 1, so u is equal to 1. So making all these transformations, I now have the integral as u goes from 0 to 1. And then I start with an x here, but remember that's u plus 1. And then I have the square root of u, and then dx is just du. So now our integral has been taken entirely to u space, and we can just forget about x for the rest of the problem. To proceed with this integral, we're going to distribute the square root into these two terms. And remember, our square root of u is just a u to the 1/2. So u to the 1/2 times u is u to the 3/2. So we're just getting simple power functions here. And then square root of u times 1, that's just a u to the 1/2. So now we apply the power rule to finding the antiderivatives here. So I add 1 to the exponent and divide by the resulting number. So the first term gives me a u to the 5/2 divided by 5/2, which is the same as multiplying by 2/5. And then I add to that a u to the 3/2 divided by 3/2, or multiplied by 2/3. So we're going to evaluate this whole thing from 0 to 1. And I notice immediately when I sub in the lower limit here, both of these terms just vanish, so I don't have to worry about that one. All I have to do is replace the u's with 1s, and I have my final answer. So that's 2/5 plus 2/3. And our common denominator there is 15. So in our first fraction, I multiply by 3/3, and I end up with 6/15. In the second one, I multiply by 5/5, and I have 10/15. And we put it all together, and we get 16/15, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.